Hi, let's take a look at how to build and run Clojure projects with the tools Clojure provides. Let's check the diagram. Clojure works on JVM, and in order to run your project on Java virtual machine, couple steps need to be performed. The dependencies you rely on should be resolved and downloaded, and then class path should be prepared. And a class path, it is a word from Java Real. It is a list of folders where JVM will look for classes that your project rely on, and folders where your dependencies were downloaded goes into the class path, folders where your source code placed goes to the class path, and so on. And as the last step, Clojure compiler should run your code on JVM, and the class path will be passed as an option to JVM. To perform all the steps we mentioned, Clojure provides us with three pieces. First is a Clojure CLI. It is a command line interface. It consists of two scripts, Clojure and CLG. They're basically the same, and I will show you the difference later. But with the help of that scripts, you can run REPL, run your projects from source code, and run some additional helper tools. Next is the deps.edn configuration files. In those files, we store the map with configuration for your project. It can contain information about folders that your project use and all libraries that your project depends on. Another thing is the tools.deps library. It does all the heavy-duty work. It resolves dependencies, download them, and build the class path. Most probably you will never use it manually, but it's nice to cover it because it gives a bit more understanding about how all that build and run infrastructure works in Clojure. And we'll cover it today. And altogether, it works like this. Clojure CLI, when started, knows about where all configuration files stored in your system. It takes information about that and passes it to tools.deps library. And tools.deps library makes all the heavy-duty work. It works with dependencies and builds the class path and returns it back to Clojure CLI. And Clojure CLI then starts the JVM with needed options and passes the class path to it. At first, let's take a look at command line interface. Sorry for interrupting. Material for this video was recorded in Ukraine a couple days before the war started, in the city that now one of the most bombed ones. So there is a big chance that you won't see the same white IKEA shelf behind me in the nearest time. Due to all these circumstances, in the description I will leave the information for those who want to make some donations. Half of the donations will be spent for humanitarian aid for Ukraine. They will be transferred to people who I personally know and who are working on buying and delivering essential medicines to civilians affected by war. And the other half will be used to make new videos. So feel free to check out the information in description, and of course your likes, comments, reposts are very welcome. Enjoy watching. We have two scripts, CLG and Clojure, and they're basically the same thing. Let's take a look at CLG. As you can see, CLG simply runs Clojure script, but it wraps it in a tool called rlwrap. What rlwrap does, it gives you a convenient editing from command line. So let's say we will run the Clojure script itself. It starts REPL, and as you can see, for example, I print something, and when I want to get back, I'm pressing up arrow if I want to call the previous statement, previous expression, I can do this. So, but when you call CLG and do the same thing, you can move around, you can call something, and you can press arrow up to bring the recent expression. And this is what rlwrap gives you. Clojure command line interface has a bunch of options, and to check them you can use a help switch. You will see there are a lot of them, and we will cover some, and mainly we'll go with these exact options, -m, -t, and -x. And we'll start from -m. -m switch gives you access to Clojure main namespace, and you can read about it on the Clojure official site. I will put the link in the description. Clojure main namespace takes a bunch of different options itself, and it provides a bunch of functionality like evaluating of expressions, running REPL, but what's most interesting for us is running scripts and running the namespaces. Let's take a look how it works in the code. Here we are in a test.deps folder. It is empty folder, it will be our project directory. Let's create here subfolder for sources, and here subfolder for dev part. And we'll have a core CLG here. Let's add very simple main function. All it does, it just prints main function called string. And let's run that namespace from the command line. So we need to call CLG, pass -m option, uppercase M, and that will be an entry point to Clojure core namespace. Then we will put the option for Clojure core namespace itself, and it is -m lowercase, and name of the namespace. Let's call it. Here we have our main function called. Another useful application of CLG -m option is to run the file as a script. Let's add our script CLG. Let's add very simple expression to our script, and it's just printing a string. But we also use here predefined name. It is command line args, and this name is binded to the list of all arguments you pass to your script. So for example, let's say we call that script from command line interface. To do this, we need to pass -m option and then specify name of the script and the options we want to provide. Here we call it, and here we can see that all the options were packed as a list and they're accessible from the script. We covered a bit -m option, and let's go and take a look at -x option. -x option allows you to run particular function from the namespace. It is not restricted to only main function, it can call any function. So let's say we have a function called print-args, and all it does, it prints arguments. Important note that argument of this function should be a map. And if you are going to write a function that will be called from command line using -x option, make sure it has one argument and it is map. To run that function from command line, we are using -x option. We are specifying the name of the namespace where our function resides and the name of the function. Now to pass the argument to that function, we have two options. First, we can specify all the keys and values as a sequence of options to our command line interface. Let's see, like we have key 1, value 1, key 2, value 2. Let's run it. And as you can see, our function took one argument and it is map. And another option, we can pass the map straight away. As a single option. The result is the same. The difference is only in the amount of options you are passing to command line. Another option that we will take a look at is -t. With -t option, you can run so-called tools, and they're external programs. They are not really related to your project, even when you run them from your project folder. To run some tool, you need to specify its name after -t option. And there is one tool that's already known to Clojure, and it's called Tools. And with the help of that tool, you can check what other tools already installed on your system, or you can install one or remove some. So for example, let's run tools tool with a list option, and we can check that I have two tools installed. And the one is the default one, tools, that we just run. And the other one is a CLG new, which I won't cover here, but we will try to install another tool. Let's take a look at tool called tools.deps.graph. And it is available on GitHub. And with the help of this tool, you can create nice diagrams of all dependencies on your project. In order to install tool, we need to run CLG with T option, run tools tool, and run its command install. In fact, tools work much like -x option. So that install command, it's actually a function and you need to pass arguments to it. The same arguments, same way as we did before with -x. In options to install, we need to specify where to find our tool, where it should be downloaded from. So in our case, this is GitHub, and we specify the version, the tag of the tool. And also we will add a as key that we can use to name our tool, like this, deps graph. And we can see that command line interface says that it installed deps graph, and we can check it. Okay, here we have deps graph installed. Now when our new tool installed, we can run it. We are using the -t option and specifying the name of our installed tool, deps graph. And we need to provide an entry point, like with -x option, what function of the tool we need to call. And in our case, it is called graph. We don't need any arguments here. Let's start it. Yeah, it thinks for some time. And here it shows us the nice small dependency graph. So far, we were covering Clojure command line interface. So let's move to next part of our diagram. And next one will be configuration files, deps.edn. So far, we don't have deps.edn file, so let's create it. And when it is created, let's try and run our core CLG again. As you can see, there is an error that says that edn map expected in our deps.edn file. So to fix it, we need to specify an empty map. Let's try again. Okay, now it works. Main function called. And to start exploring keys that can be used in deps.edn file, let's create a new sources folder. Let's be test. And we can create a new file here like core test CLG. Let's add a very simple main function to our core test namespace. And let's try to run it. We are getting an error because so far Clojure doesn't know that it also should look for files into test folder. By default, Clojure looks for sources only in src folder. But to change this, we can go to our deps.edn and add new key called pass. The content of that key is a vector of our folders where our source code can be placed. So we need to specify src here because we are not using the default values anymore. And we need to specify our test folder. Now save it. And let's run again our core test namespace. Here it is. We have output. So it works now. Next important key that we can cover is deps. Under deps key, we specify all the dependencies our project rely on. For example, we so far used println as our printing function, but let's use some sophisticated one. For example, timber. I hope I pronounce it correctly. Here is this project. On the main page of the project, listed how timber can be installed with the deps.edn. With the help of this line, let's copy it and put under our deps key inside the map. Let's take a look what we've added here. We've added a key value pair, and the key here is the name of library that we are going to use. And the value, it's actually a maven coordinate of that library. So it says that that library stored in maven and its version is 5.1.2. Now when we've added dependency to deps.edn file, we can use it. Let's add the require for timber library and use it instead of println. And run our namespace. This is dev core. Okay, you can see that our new output already uses new logger system. Let's add one more dependency, but this time not from Maven, but from GitHub. There is a test runner library that allows you to run all the tests that you have in your sources folders. On the main page of the project, we can find information on how to install this library. Here it is specified under extra-deps key inside the alias, but let's wait a couple minutes, we'll get back to it. It is sufficient for us to use the same information, but use it under deps. So we have added our test runner with this key and this value. And you can see that this time this value references two additional keys, git tag and git sha. This is done because git can be changed, and if you reference on some specific version of library, like here 050, in fact it can be changed on the repository side and will be switched to another commit, and that would be very inconvenient for you and potentially dangerous. So you also specify the sha key to make sure that library is always of the same version that you are going to use. Now, when we referenced our test runner in deps.edn, we can run it. We don't need to use it in the source code because it's runnable from command line. Here's the command. As you can see, we are specifying the -m switch, so we are running like main function of Cognitect test runner namespace. We run it. And we see, okay, it's run 0 test because we don't have one. Let's add very simplistic test. Will look like this. And we also need to reference Clojure test library. And let's run our test runner again. And you can see that test was run successfully. So as you can see, with deps.edn, with deps key, we can specify what kind of dependencies we want to download and from where, from Maven or maybe from Git. And it is also possible to reference some local libraries or maybe some jar files, but you'd better go to official documentation to see all the possible ways of using it. And I will put the link in the description. We have covered passkey and deps key of deps.edn file. And the next key that we want to cover is aliases. And aliases is an extremely important one. With aliases, we significantly reducing amount of typing in command line. Let's take a look at the example. We have dev core file, but let's say we also want to have one more version of that file for production. And for production, we want to run our application from it. So let's create a folder prod and another core CLG here. It would be pretty similar. Difference is prod. And we will do these changes to make a distinction what kind of function we call from dev over prod file. To run the development version, we are running our dev core like this. And pretty much the same for production mode. Here we can ensure that different namespaces were invoked. Let's reduce amount of typing and create an alias for production mode. To create a new alias, you need to add a new key value pair to aliases map. And the key will be alias map. So in our case, we will name it prod. Let's make it shorter. And value for that key will be a structure. And that structure can contain different predefined keys that command line interface understands. In our case, since we were using -m option, we need to create a map with main opts key. And the value of that main opts key would be a vector of that keys that Clojure main namespaces can understand. So those one that we used in CLI. It is -m and prod core. Now, we can use that alias with -m option. Let's run it. And you can see here we have the same output that we had before. So to summarize, if you want to make a shorter version of your command that uses -m option, you can put all the options after -m into the alias under the main opts key. Those are predefined key. And when CLI sees that key in the alias that you run, it will pass all them to Clojure main namespace. Let's add similar alias for our development. Okay, here we have alias dev, and it runs dev namespace. Those were aliases for -m option, but we can also create aliases specific for -x option. Let's create a new file that will contain the function that we want to run from aliases. Here is our function. It is imaginary function for generating reports, and it takes some options. It takes map with two keys, type of the report to generate and tables that should be used from some database to prepare that report. And here in the output, we will print exactly what type and what tables were used when you invoke that function. Okay, let's try and run this from command line. We're using -x option to reference specific function, and that will be reports generate. And we want to specify type, for example, pie chart, and tables that should be used, for example, users and customers. Okay, we can see the output, that pie chart generated for tables. But as we can see, the typing of this command is pretty tedious. So let's create an alias. Aliases for -x option of CLI depend on different predefined keys. They don't use main opts. So let it will be generate pie chart. This is the name of our new alias. And the first predefined key that we will rely on is exec-fn. Here we specify what function we want to use. And another key, exec-args. Here we should pass our arguments. And here we had what? Type pie chart, tables, users, customers. Saving this, and let's run this alias. Okay, here it is. As you can see, quite significant reducing of amount of typing. And we can add one more alias, for example, to generate diagram. It will be a type diagram. Let it be for the same tables. We are running with X option our new alias. Okay, here it is. It is of type diagram now. So let's go back to our deps.edn and take a look again at all the aliases we've created. When we create alias that target specifically -m option of CLI, we are using predefined key main opts. If you run this alias like prod or dev with -x option of CLI, you will get an error. It says no function found on command line. So main opts targets specifically -m. Same way, if you want to create an alias that targets -x option of CLI, you're using exec-fn predefined key and exec-args predefined key. But there are also keys that you can use in your aliases, and they're not strictly tied to some particular option of CLI, and they're like universal. Let's take a look at some. A couple minutes ago, we were running test runner from command line, and here's a command to run it. Let's create an alias for it. So let's name it test. And since we were running it with -m option, it will have main opts predefined key with vector of options -m and name of the namespace to run. Okay, here it is. And let's run it. Okay, it works. But now when we've created our alias, we can take a look at our deps.edn and figure out that our path test and our dependency on Cognitect test runner doesn't really have to be in the root. They all belong to alias for testing. So outside of that alias, we don't need either test folder, either the dependency on Cognitect text runner. So move them inside the alias. And to do this, we need additional couple predefined keys. And the first one is extra-path. Inside the extra-path key, we specify a vector of paths that are needed only when our alias executed. In our case, it is test. And we can get rid of our test reference in global path key. And another key is extra-deps. And inside that key, we need to put dependencies that are required only when our alias executed. In our case, it is test runner, so we can remove it from here and put here. Let's try and run our test alias again. Okay, it works fine. And let's also try and run our production alias to make sure that we haven't broken anything. Okay, it also works. So these keys, extra-path and extra-deps, can be used with any alias, whether it should be run with -m or -x, and they will be taken into account anyway. Okay, so far we've covered aliases, deps and paths, and figure out how to reduce your typing in command line using aliases. So we can get back to our diagram. But one moment, you can see that there are a couple of deps.edn files depicted here. This is because, in fact, there are not only one deps.edn file in your system. Here we have a created one, but there are also a couple already existing. Let's find them. To find them, let's use this option of CLG. It shows you environment where your project will start. And there is a key config files that you can investigate and find that there are one deps.edn file located in the installation of your Clojure. And there are also one deps.edn file located inside your user directory. In my case, it is empty, but we can take a look at the content of this one. Here is deps.edn file located in our installation. You can take a look at it and figure out that there is a path key that already mentions src. And this is why we didn't have to create our deps.edn the very first time. We were able to run the project even without it, because we already have the default one and it already looks into src folder. Another interesting key is maven repos, and it says in what maven repositories command line interface will look for your dependencies if they are maven dependencies. So if you have some private maven repo, you can list it in your deps.edn file under the same key, maven repos. And now, when we've covered a bit of CLI and a bit of deps.edn files, let's take a look at tools.deps library. You probably won't ever need to use the tools.deps library directly, but it's nice to understand how it works inside to have a better understanding of how all that system works. Here we have one more diagram. And on this diagram, there is a deps.edn file and tools.deps library and the relation between them. So at first, let's take a look at tools.deps library. It does all the heavy-duty work of resolving dependencies, downloading them, and creating the class paths. And we can treat it as the one that contains like two entry points, resolve-deps and make-classpath-map. Both of these functions will be called by CLI when you run CLI script from command line. Resolve-deps function takes two arguments, deps and args-map. And the first argument is actually a list of your dependencies listed in a root of your deps.edn file. And the second argument is a list of dependencies and all dependency-related keys that listed under alias that you are currently executing. So for example, if you have some dependency inside deps, and you also have extra-deps key specified in your alias, those two dependencies will be merged together and they both will be resolved and downloaded. But there are also additional keys that you can specify in the alias. Override deps. It is a predefined key that you can use in alias to specify what versions of dependency you want to override with another versions. Default deps key allows you to specify what dependencies should be used if there are no deps specified in the root key. And the replace deps allows you to totally ignore all the dependencies that are specified in root deps key and use own instead within your alias. When resolve-deps will take the dependencies from your root key of deps.edn file and all that additional predefined keys that you listed in your alias and that affect how dependencies should be resolved, it will, as a result, calculate a libraries map. And that libraries map will contain all the information about dependencies you rely on, their location on your local disk, their versions, and additional information like what other libraries depend on this particular one. And that map of libraries will go as a first argument to another function that we will cover, make-classpath-map. This function takes all information about libraries that are used, about folders that you use in your project, and builds class paths that will tell the JVM all the folders where it can look for Java classes. The first argument is a libraries map from resolve-deps. The second argument is actually all the paths that you are using in your deps.edn file. And the third argument are all predefined keys that are related to paths that you were using in your alias. There are 3 path-related keys that you can use inside the aliases. The first one is extra-path, and we've already covered it. The second one is class-path overrides, and it allows you to specify some library and its alternate location. For example, if you want to use test version of a library. And replace path key allows you to totally ignore all the content of paths key in the root of deps.edn file and use the content of replace path instead. And eventually, when make-classpath-map will start and will take into consideration all the keys of your deps.edn and all the arguments that you provided in your alias, it will create a class path, a list of paths that will be passed to JVM to run your project and find all the resources you rely on. So yeah, as I said, probably you will never need to use tools.deps directly, but I believe that looking at this diagram will make it a bit clearer on how to use predefined keys inside your aliases and how they really affect the internal work of all that CLI. By the way, if you want to know what class path calculated by your CLI invocation, you can use this option. You can specify the alias that you are going to run, and you can see the class path that was built for that invocation. Or for example, let's run alias test. Okay, there are more information on this class path because we, in this invocation, using the test folder like this, it is not here. And also we use Cognitect test runner, and we don't rely on it when we are running our dev alias. At this moment, you are fully ready to build and run your Clojure project, but there are more options to CLI, and you can investigate them by running clg help and looking at the output. And I encourage you to do this and to take a look at official documentation on CLI. Now, when you know how to build your Clojure project, it would be useful to learn how to package your libraries into jars and your application into Uber jars for distribution. And Clojure provides a tool to do this. It's called tools.build. So go ahead and check out my next video on this topic. My name is Volodymyr, and I hope you like the video. Please let me know in the comments what do you think about it, and I hope it was your like. And see you in the next videos. Bye!